everyone, my name is Keith Solsona.
And my name is Francesca Calingo.
Welcome to our math class. We will be your teacher for today
from the
from
Group
the Group 5 of Grade 11
St.
St.
Bartholomew.
Bartholomew. We will be discussing rational equation and rational inequality.
Yes, Keith, we will be explaining about what is rational equation and rational inequality is all about, and we will give you some examples for you to understand.
Our goal for today is to determine the meaning of rational equation and rational inequality, and we will solve examples for you guys to understand our lesson. Patch, can you give them the definition of rational equation and its examples? And I'll be the one to explain rational inequalities.
Sure, Keith. A rational equation is an equation containing at least one fraction whose numerator and denominator are polynomials. These fractions may be on one or both sides of the equation. A common way to solve these equations is to reduce the fractions to a common denominator and then solve the equality of the numerators. We can also conclude that rational equations is equations that contain rational expressions. For example, so the first one, we have a negative 2 over x plus 5 over x is equals to 6. Well, in this case, we already have a common denominator. So that means we can simply write it as a single fraction. Negative 2 plus 5 over x is equals to 6. You can simplify the numerator here. Negative 2 plus 5 over x would simply be 3 over x is equals to 6. Here, you can just multiply both sides by x, but again, just to illustrate this idea of cross multiplication, you could think about 6 as being 6 over 1, and again, we can cross multiply and we take the stuff in the denominator or one fraction, multiply it by the numerator of the fraction. Okay, so on one side, it doesn't matter which side of the equal sign you put the stuff as long as you know one part goes on one side. One part goes to other side, so I could write 3 times 1 on the left side, then I would have times 6, which I'm just going to write it as 6x on the right side. And now we just have 3 is equals to 6x, and if we wanted to solve for x, we simply divide both sides by 6, and 3 divided by 6 would be the number 1/2, and you can check that if we plug 1/2 back into this original problem, we will get the value. When you plug it into the left side, we will get 6 out of our solution. Let's move on to rational inequality. Keith will explain it to us.
Thanks, Patch. An inequality, on the other hand, is a statement that uses the symbol less than or greater than to denote that one quantity is larger or smaller in value than another. Like an identity, an inequality holds values for all variables. It focuses on the inequalities of two variables with one as their exponents. A rational inequality contains a rational expression where a rational expression is a ratio of two polynomials. That is, a rational expression is of the form Rx over Qx where Rx and Qx are polynomials and Qx is not 0. Our example is this: x minus 3 over x plus 2 greater than 0. Equate the numerator to 0, x minus 3 is equals to 0. It will change the sign and our x will be positive 3. Repeat the step with the denominator, x plus 2, and our x will be negative 2. Our critical points now is 3 and negative 2. Remember, when drawing a number line, the dot should be a solid dot if the denominator is not 0. But if the denominator is 0, it should be a hollow dot. The intervals are x less than negative 2, x less than negative 2 and less than negative 3, and x greater than 3. To get the test points of the first interval, find a number that is less than -2, let's say -3. For the second interval, just choose any number between -2 and 3, let's say 0. For the third interval, choose any number that is greater than 3, let's say 4. The test points are -3, 0, and 4. To be able to make a table of signs, let's replace x with -3, 0, and 4. To solve the next equation, add all the test points to the given. Let's solve the first column. -3 minus 3, we will have a negative answer. And -3 plus 2, we will also get negative. For the second column, 0 minus 3 gives us a negative answer. And 0 plus 2 gives us a positive answer. For the last column, 4 minus 3, we will have a positive value. And 4 plus 2, we will also get a positive value. To get the last part, multiply the signs in x minus 3 and x plus 2. Negative plus negative, the value is positive. Negative plus positive, the value is negative. Positive plus positive, the value is positive. And that's how we get our values for the last column. That's how we get the rational inequalities. And that's our lesson for today. We hope that you enjoyed listening and that you learned something. Please don't forget to like, comment, and subscribe. Again, this is Keith and Patch of Group 5. Thank you for listening.